Hi everybody, welcome to a new episode of the Dissenter. Joining me today is Dr. Peter Carruthers. He is a British-American philosopher and cognitive scientist working primarily in the area of philosophy of mind. He is professor of philosophy at the University of Maryland, College Park, an associate member of the Neuroscience and Cognitive Science program, and member of the Committee for Philosophy and the Sciences. He is also the author of many books like The Philosophy of Psychology, The Architecture of the Mind, and the editor of the trilogy Innate Mind. Dr. Carruthers, thank you a lot for taking the time to come on the show.
You're welcome.
Okay, great. So today we're going to talk a little bit about your work, particularly on the innateness of the human mind, massive modularity, language, natural language, and things like that. So the first question I would like to ask you is, when you talk about in your work about the innateness of the human mind, what does it mean, and what features does a particular feature of our mind have to have in order for it to be considered innate?
All right. Okay. So I pretty much endorse the view of innateness that Richard Samuels has defended in a number of publications. That say, at least in the cognitive domain, to say that some feature of the mind is innate is to say that it's acquired in normal development. So it's just to rule out things that you get through a bang on the head or something, but not as a result of learning. So roughly speaking, something is innate if it isn't learned. And that's pretty much the notion of innateness that was there in the debates about innateness way back in the Enlightenment. And I think it's pretty much the notion that's at stake when people debate how much of what happens in infancy is a result of learning and how much is a result of what's there as part of the learning mechanisms at the outset. So I think the debate is really about, everyone has to allow that something is innate. The learning mechanisms have to be innate, right? Because they aren't learned. You on pain of vicious regress, you can't learn how to learn in any realistic sense. So the debate is about how richly structured those learning mechanisms are, whether it's all general learning or whether there are specific learning mechanisms for specific types of domain or specific types of problem that humans face.
Mm-hmm. Yeah, exactly. And what you just said is very interesting because there are people who espouse the idea, particularly people that come from that walk of that theory, let's say, as, for example, people like Dr. Lida Cosmides and John Tooby wrote about in their adapted mind, that they called the standard social science model, that there are people that believe that we are born with simply some general learning mechanism and nothing else. But even that would be innate, right?
Oh, of course, that would be innate, yes. But so it's best to think of the debate between empiricists and nativists as a spectrum. Everyone has to allow that something is innate, and then the debate is about how much and what exactly is innate.
Mm-hmm. Yes, exactly. And also related to what I've just said about the work coming from evolutionary psychology in this case. Okay, so evolutionary psychologists and other people say or espouse the idea that the human mind is divided into modules, in this case cognitive modules, and the idea of the massive modularity of the human mind. And you also do so. So could you please explain what is the scientific/evolutionary rationale behind it?
Oh, okay, so numerous really. One is simply putting human cognition into a comparative perspective. We know that other animals are not general learning mechanisms, right? We know that they have cognitive adaptations for either figuring out where north is. If you're looking at bees, for example, they learn the solar azimuth and can do their computations for where to go on that basis. We know in other animals that there are some cognitive capacities that are there as soon as they open their eyes, right? So some of the work that Valtiorguera, I'm not sure I'm pronouncing his name right, he's an Italian neuroscientist, has done with newborn chicks, that they already have the geometry of the world there in place as soon as they hatch out of the egg and open their eyes. So for sure that's not general learning or learning of any kind, right? So that's part of the innate structure that's there from the outset. And it would just be weird if all that structure that was there in our evolutionary heritage somehow disappeared when humans came on the scene, right? I mean, how would that happen? That we know that brain mechanisms are highly conserved. We know that just about everything else about mammalian biology is highly conserved, and that all of cognition should have been swept away and we start again with a blank slate, literally a blank slate. Just makes no sense at all. Then there are broadly computational arguments which say, well, learning about different domains face different challenges, right? That you need different computational principles to learn different things. And we know, face recognition, for example, is a pretty specialized thing, but as we now know, not entirely specialized, because the fusiform face area, which is now thought to be located in the right, is actually bilateral, and the left fusiform face area gets co-opted for reading. Right? So if you look at face recognition in people who are illiterate, the fusiform in both hemispheres is what does the work. But when you get to be literate, the left takes over for words and the right stays with faces. Right? But if you have bilateral damage, you've just lost it. You can't either read or do faces. Right? So that whatever computational properties that has to do with complexities of shape and holistic processing that goes into faces and word recognition just can't be taken over by other structures. And then there's more general arguments that in general evolution proceeds piecemeal by kind of adding on little bits and pieces and altering structures without totally building things from scratch.
Mm-hmm. Okay, and so could you please explain or tell a little bit more about what are the main characteristics or the main features of each module? Because there are people that think that if we are to classify our cognition or organize it in terms of modules, that what a module means is that it receives a certain kind of input in terms of information, it processes it, but it would work in a sort of isolated way, and it wouldn't share information with other modules. But that isn't really how modularity works, right?
No, I mean, so to be honest, I've stopped using the language of modularity because some people just can't get that photo modularity notion out of their heads, right? And they just hear it wrong. But the thesis of massive modularity is, you can express it without using the term, it's the thesis of massive functional specialization. And that's pretty much all it amounts to. So you say the mind is going to be divided into specialized processes which do their own specific job and interact with others in ways that are distinctive of the kind of job that they do. Certainly, I don't think any... I pause to think, hang on, is this entirely right? Well, I certainly don't think that the parade encapsulated systems for Fodor, when he put it forward, and he thought the mind wasn't massively modular, but just input systems were modular. They're not modular in his sense. I don't think vision is encapsulated. I don't think audition is encapsulated. On the contrary, I think you have complex top-down interaction with the incoming information from pretty early stages. And I think, well, my own view is we know that pretty much for sure. I mean, there are some holdouts out there who don't believe it, but I think most people in vision science think that's true.
Mm-hmm. Okay, so just for people to understand it a little bit better, so what gave rise to these cognitive modules from an evolutionary standpoint? Was it the fact that we had to deal with each particular kind of adaptively relevant problem in isolation or even in combination, but that there were parts of our mind that that had to be specifically dedicated to solving particular kinds of problems, and so to be directed at receiving particular kinds of inputs of information.
Yes, I mean, so some of it is just inherited from other mammals, right? So the basic 3D structure of the world that's given to us, I think from the outset, is just the same mammalian structure that's been inherited way back, and I mean long before mammals too, right? I mean, essentially all creatures represent the world in 3D ways, and we know even back to bees, they have a sort of map-like representation of the environments in which they live. So a lot of this stuff is just part of our inheritance as animals. And yes, then there are adaptive problems that humans particularly faced. I mean, I actually think many of them had to do with culture and cultural learning. I mean, that's our niche. We're cultural creatures. And so there are the adaptations that make faces particularly salient, that make us pay attention to the actions of others and try and figure out what it is that they're doing, make us automatically mirror the actions of others whenever interacting with them to establish a kind of rapport and so on. Yeah.
Mm-hmm. Okay, so, but each module would be specialized to deal with a particular kind of problem that, in our case, we ourselves as humans had to deal with in our evolutionary history.
Well, no, I don't think all modules or all specialized processing systems are innate. I think that I like to think of, and actually people who do action science think that whenever you learn a new skill, in effect what you're doing is building a little behavior control module in the motor control system, which is one reason why learning new skills can interfere with old ones, right? Because if you are learning a skill that overlaps with an old one, it can mess up the module that you've already built for that, right? So I think skill learning is actually about constructing little behavior control modules that will enable you to do a specific task. And then there's a more general skill acquisition mechanism, right? There's the computational processes that enable you to build those behavioral skills, which is innate. So skill learning, I think of as just another innate learning mechanism, but the outputs of those are also modules in this case. They're specialized systems. I mean, some people think that I mean, I know Dan Sperber likes to say that every concept is a module. I mean, you know, that it's a little specialized processing system, and that's fine too. I mean, I think it's stretching language a bit, but if we're not talking about modules anyway, that doesn't really matter. It's a specialized processing system that's acquired and that does a particular job. Yeah.
Okay, and what would be left unexplained, or at least unsatisfactorily explained, if the mind wasn't to be organized in modules, but that we rather had simply domain general learning mechanisms?
Well, our connection with other animals, for a start. I mean, it would be left unexplained how some radical evolutionary transition took place between other primates, who for sure aren't general learners, and us, if suddenly, given that the primate brain evolution was not entirely, I mean, essentially the architecture has stayed the same. It's expanded, and there's been extra expansion in prefrontal cortex, but a lot of that structure is still there, and we use primates as models when studying the brain, right? So it'd be really weird. You what would be left unexplained is, how did that happen? How did suddenly it all get to be a blank slate? And I think also my own view is that you struggle then to explain a lot of the infancy data, which has really started to build over the last 30 years, suggesting that human infants are a lot smarter than people used to think. They know a lot more, they learn a lot faster, and it's really hard explaining that learning in terms of general learning principles. Or that's my view. Yeah.
Okay, so when we're talking about something that is innate, usually people oppose that to what comes from the environment in terms of influences. So specifically about the prenatal environment, and because we call it also environment, right? Would you say that it should be also considered a part of the environment, or because what results from it in terms of the structural organization of our brain and that we are born with that should also be considered innate?
All right, so both, right? So we know some learning takes place prenatally, right? So to the extent that not innate means learned, right? Then yeah, there's some stuff that happens prenatally that isn't innate. So we know that infants can recognize the accent and the language that their mother uses as soon as they're born, and there's other kinds of learning that seem to take place too. But most of what happens in utero is not about learning. Right, so if one is to use the language of innateness here, I don't think it makes any sense when you switch into what's genuinely the unfolding of a biological program which is interacting with in utero influences and chemical influences. I mean, I think that it certainly isn't acquired characteristics, right? I mean, with biological systems, you can distinguish between the normal development of the biological system, which is interactive all the way down, environment and genes and intracellular and extracellular processes and so on, from things that are definitely acquired, like, a lost finger, right? I mean, that's an acquired characteristic, and that certainly isn't innate, but doesn't really make any sense. But the basic organization of the human brain, for sure, is not learned. Right? I mean, and the long-range wiring connections in the human brain are not learned, and actually looks like they pretty much can't be changed either. I mean, to the extent that there's flexibility in the brain, it's local. I mean, things can take over local functions, but the long-range neural pathways seem to be fixed from the outset. Well, from in utero. Yeah.
Okay, so I would also like to ask you, from the evidence that we have at this moment, coming from science and the several sciences, do we already know what is the content of our thoughts? I mean, is it mentalism, as some people propose, that is a sort of language of thought that is not really verbal? Does it occur in terms of images? So how does it work, really?
All right. So I think you mean bearers of our thoughts, or the representations rather than the contents of the representations. But yeah, and some version of mentalese, I think, is probably right. I think that, again, all animals, all the way down to bees, have structured representations of the environment. I mean, in many cases, you probably wouldn't want to think of it as a propositional representation. So in the case of bees, it's more map-like, but it's still structured out of components, and those different, when bee experimenters put a landmark in place and the bees learn that, and then they move the landmark, and the bees have to then take what they knew about this and shift it elsewhere on the map. It's thought-like. So we have map-like representations. I think we also have propositional-like representations, often represented in terms of generics, right? So where you have a node for cat, as it might be, and you have a belief that cats meow and cats lap milk and cats are furry and so forth, that are all linked to the generic, and then exceptions, as with birds fly is our generic belief, but of course we all know about penguins too. So yeah, I think the basic structure of our thoughts is some form of mental ease. Of course, when you switch then to the perceptual domains, then those structures are non-conceptual, something like images, if we're looking at the visual domain. But I mean, auditory representations are quite different. They're not in terms of, well, I mean, they're not image-like, right? Yeah. Okay. So mental ease, I go for mental ease.
Okay, great. So, and what is the role that language can play in our cognition? Does it allow for a certain flexibility of our cognitive modules? Does it allow for information to flow, let's say, more easily between modules?
No, I once defended a view like that on what I thought was the evidence at the time. Back in 2002, I had a BBS paper that did this. But by the time I did the Modularity of Mind book, I thought the evidence no longer supported that view, and I still think it doesn't really support that view. For sure, having language adds a bunch of stuff to human cognition. I mean, it's the medium through which most of our beliefs come. It's through language learning, it's the medium through which many of our concepts come, right? So, I mean, of course, there's concept acquisition without language, but as soon as you're learning a language, kids are picking up concepts to latch on to words at an amazingly fast rate for a really early age, and we end up with hundreds of thousands of concepts as a result. And merely by virtue of being able to speak, you can formulate thoughts, not necessarily that you couldn't formulate before, but that you can say something and then think about what you've said, right? So, you know, take the Shakespeare example of Romeo saying, Juliet is the sun, right? Now, could an animal think that Juliet is the sun? Well, it's unlikely ever to do so, right? But when you've got a language, you've got these terms, right? And you can combine them into a sentence, and you can utter the sentence and then evaluate the sentence and think, well, is there anything useful there? Is it? And in that case, yes, it's a marvelous metaphor to use to describe what Juliet means to him. So yes, I think once you get language, you can kind of try out stuff in language and end up thinking thoughts that you perhaps would never have thought before.
Okay, but so would you say that language, at least to a limited extent, alters the way our cognition function, at least at a conscious level?
Oh yeah, it plays a significant role in cognition. It's disputed exactly how universal that role is, right? So when people do introspection sampling studies, some people, probably like you and me, who are academics of one sort or another, seem to be engaging in inner speech almost all the time. Other people rarely report it. Now, it's not entirely clear what to make of these data, but for those who do employ it, it's certainly an important medium of cognition. I think probably for those who don't employ it, it still has a big influence too. Yeah.
Okay, and what is the importance of creativity for human cognition, and why was it important? Why was it important for it to arise during our evolutionary history?
Oh well, I mean that's disputed. Some people have argued that it was essentially a mating signal, right? It's a kind of showing off. It's like the peacock's tail. It's how you show your fitness, that you're smart. You can make jokes. You can say things that no one's ever thought of before, and so on. And I'm kind of neutral on that. I mean, I think we just don't know what the initial evolutionary pressures were. But for sure, it can be adaptive in other ways too now. That's where invention comes from. That's where science comes from. That's where, I mean, at least a significant part of cultural accumulation comes from. I mean, so some cultural acquisitions are just accident and people fall into them, but some of it's people having an idea and trying it out, and yes, it works, and then that gets passed on to the next generation and so on. Whether that was the adaptive force, or whether it was more to do with mating and that then got co-opted to be useful in other ways, or vice versa, I don't know for sure. That plays both roles now, right? So people admire the creative rapper or the creative singer or the creative musician or the comedian, right? Those people get revered, and for sure scientific invention requires creativity, and so it's not clear which would be primary, evolutionary speaking, I think.
Mm-hmm. So would you say that creativity would have played the more relevant role from a cultural evolution point of view?
So if that's an interesting thought. If what you're asking is was there cultural cognitive co-evolution for creativity? Yeah, maybe. I mean, I hadn't thought that thought before, and now you put it into words for me. I think that's kind of a plausible hypothesis, but I don't know. Yeah.
Yeah, because I mean, I already had an interview with, for example, Dr. Robert Boyd, and he comes from cultural evolution, and he was one of the main authors of culture-gene coevolution or dual inheritance theory, right? And this just came to my mind, that perhaps creativity could have become more relevant from an evolutionary standpoint when applied to cultural evolution and not really genetic evolution, maybe.
Yeah, no, that may be right. I mean, I know Rob's work and think very highly of it, and that might be the right context in which to see it.
Mm-hmm. Okay, and so from your point of view, is creativity always action-based? That is it always related to the generation and mental rehearsal of action schemes or schemata?
So I did hold that view and pushed that view in a couple of publications, in part because I thought it could put creativity into an evolutionary perspective. So one thing that many people say about creativity is it involves a kind of stochasticity, a kind of randomness. Okay, now that's easy to understand when it's external randomness, right? It's two scientists who happen to meet on a train and from different backgrounds, and in their conversation something new emerges. Or there's the famous case of penicillin and the growth in the petri dish, right? But a lot of creativity, the stochasticity is internally generated, and we do have a model in the action domain for, or we do have knowledge that in the action domain, in other animals, they display that kind of stochasticity, and that's in the so-called protean behaviors of animals that are particularly prey animals when they're fleeing a predator. So if you think of the gazelle that's running away from a lion or a cheetah, it does this wholly unpredictable leaps and bounds and twists and turns and so forth. Because of course, if it's predictable, then the predator will get it because it'll predict where it's going to be next. And so probably what's going on, I think the best psychological theory that we have of how that works is action selection is always to some degree competitive, right? There are different affordances, different things you could do in the environment, right? And what you can do in order to get stochastic action selection is, if you've got these neural accumulators that are building up towards a threshold, right, for when choice happens, if you set a fairly low criterion for choice, but then suppress anything that meets that quickly, that'll mean you're not doing the obvious thing, right? So the obvious thing is to run in a straight line, right? But if that keep running in a straight line is the first one to reach the threshold, you suppress that and you're picking something else. And then, since you've set it a low threshold throughout, what reaches the threshold next is to a significant extent going to be a product of neural fluctuations that are stochastic anyway, right? Because there's always noise in neural systems. And so it really will be stochastic, which one, whether it's turn left or whether it's turn right or whatever it is that you pick, and you can't even predict that for yourself. So I thought there was a good story there, right? And then, as with you've got a good story, you think, well, how far can I extend it? I no longer think that that is the whole story of creativity. And in particular, if you what one needs is to draw a distinction between two fundamentally different forms of creativity, which you can think of as offline and online, right? So the gazelle running from the lion, or the rapper who's doing freestyle rap, is online, right? Or coming up with a witty comment when you're in conversation with your friends, that's online creativity. But a lot of creativity occurs when you're doing something else, right? Famously, while you're in the shower, while you're walking the dog, while you're doing something else, suddenly an idea pops into your head, and that's the way to do it. Or what about this, right? And that's not action-based. I think the way to explain that is through the so-called, well, it's actually called the saliency network, but that's not the right word. I think relevance network is better. So folks who study how the contents of consciousness get determined distinguish between the top-down attentional network, which is what selects items to be globally available, to get globally broadcast, to become contents of consciousness. But at the same time, there's this relevance network that is monitoring unattended items for relevance to your goals and purposes and underlying values and so on. And if something is detected as relevant enough, it's then competing for control of the attentional network, and suddenly you switch. So that's how to explain, for example, what's always called the cocktail party effect, though I have no idea what a cocktail party is, actually. I've never been to one. Have you been to a cocktail party? I think they used to exist back in the 50s, where you're in conversation with someone, there's a lot of conversation going on around you, and someone says your name in one of those conversations, and suddenly your attention is switched. So you have to be monitoring those conversations unconsciously, right? And that's the relevance network at work. It's processing these unconscious percepts for relevance. So I think the way to explain the ideas that pop into your head while you're doing something else is all the time memories and fragments of memory and so forth are being associatively activated a little bit by things that are happening, by other things that you're thinking, by perceptual input. And those are getting monitored for relevance. And if one of your standing goals is, how am I going to solve this problem? How should I present this theory, whatever it is, then whenever something's appraised as relevant enough to that goal, it'll attract attention, pop into consciousness, and then it has to be evaluated all over again, right? Familiarly, many of the ideas that occur to you aren't any good when you actually think them through, but the initial thought is a creative one. So I now think, yeah, action selection is important for one kind of online creativity, and this kind of offline creativity is different. And interestingly, they don't seem to correlate with one another very well. So the kinds of online measures that we standardly take of creativity, think of some unusual things that you can do with a brick, right? Which you have to do fast and to time, and doesn't tend to correlate very well with measures of real-world creative achievement, which you might think of as having more to do with the offline stuff. So I now think there's at least two sides. I actually think that the online too splits into a memory-based version and an action-based version. But
okay, very well. So perhaps just one last topic on this conversation, that is, how does the innateness of mind, or the idea of the mind as being innate, allow for developmental flexibility? That is, because we have fixed cognitive functions in our brains, let's say, how does that idea allow for the fact that even so, during our development, we can get in contact with certain influences coming from the environment that then allow for us to develop certain aspects of cognition that are not really present at birth, for example?
Oh, right. I mean, so I think that most of what I think of as or many of what I think of as the innate mechanisms are innate learning mechanisms. Right? So the language faculty is a learning system. Right? Everyone should allow that language is learned. It's just, what's the nature of the learning that enables the acquisition of learning? Is it the acquisition of language? Is it general learning, or is it a specialized learning mechanism that already contains some information about human languages? And I think the latter. Social cognition, or mind reading, or theory of mind, I think of as very similar. It's got some conceptual primitives, right? So maybe it's got a notion of think in there, and a notion of want in there from the start. And it's got some simple attribution principles, right? If something happens in someone's presence, then they think it, they know it. But then that knowledge gets elaborated through learning. You're acquiring new concepts, new acquisition principles. You gradually build a more and more sophisticated model of how behavior is determined, and then particular models for particular people, given what they want and like, and so on. So for sure, humans learn an awful lot, right? Much of our behavior is a result of learning. It's just a question of whether it's a result of domain-specific or innately channeled learning, or whether it's a result of general learning. And I think most of it's channeled learning, not general.
Mm-hmm. Okay, so just before we finish this here, would you like perhaps to share with people where they can find and follow your work on the internet, and also perhaps some interesting piece of work you're doing at the moment?
So if they Google my name or Google Peter Carruthers philosophy, then on my website they can find all of my papers, information about the books, some of the really old books they can versions of on there too. What I've been working on morally, I've been going back to the consciousness issue and thinking about what consciousness is, and whether animals are conscious. And I think once you distinguish the different notions of consciousness that are often run together, right? So there's what some people call creature consciousness, which is awareness of the environment, and of course animals are creature conscious, there's no problem about that. But then there's also phenomenal consciousness, which is the so-called, the sort of feely bit, the what it's like, and so on. And that's a distinctively first-person notion. And I think it's much more problematic to extend that notion beyond the human case, because partly because you're trying to project from concepts that are essentially first-personal to this very different third-person situation. And for what it's worth, I've come to believe that there's simply no fact to the matter, but that it doesn't matter, right? Because if I'm a reductive representationalist about consciousness, which I am, I think phenomenal consciousness just is globally broadcast non-conceptual content, and we can think about that in particular ways that get people puzzled. Then as you look across animal minds, you're going to see immense a range of complexity and different kinds of similarities to the human mind and so forth. And if you ask, well, at what point in all of that complexity does phenomenal consciousness emerge? I think there's nothing extra to ask about, right? You know it all when you know how their minds work and the extent of the similarities and differences, and that's what we should be studying. Mm-hmm. So that's what I've been working on recently, in a year or so, I hope.
Mm-hmm. Okay, very well. So, Dr. Carruthers, I really love your work, so I would really like to thank you for taking the time here today to come on the show.
Yeah, well, thank you very much. It's been a pleasure.
Hi everybody, thank you for watching this interview until the end. I would also like to ask you to please pay a visit to my Patreon page and consider making a pledge if you like the work that I've been doing. And I would also like to give a huge thank you to my patrons, Karen Litzke, Anne Blanchett, Per Elga Larsen, Lau Guerrero and Chantel Gelines. Thank you for all.